Hi, so this is a quick explanation to explain what we're doing with the reverse caching proxy stuff at DoD. So from time to time, DoD gets crushed under an enormous amount of load, and it's usually one site getting hammered because it became popular. Recently, right now, it's the saltydroid site that is, I don't want to say causing the problem. I think it's a good problem to have, but it's the one that's degrading service and could speed up. So I quickly threw together a little reverse caching proxy, and I'm going to give you an idea about exactly how it works first. Let's say we have this client over here, and we're going to make a request for slash. So this client is going to send the request out to the firewall, to the reverse caching proxy, check memory, but it won't be there. So it's going to go back, go to the origin server, grab that content, come back, populate memory with the data that comes back from slash, and then send it back to the client. And so what this has the effect of doing is basically if I am now this second client and I also request, let's say I'm going to request slash, it basically gives us the ability to pull that directly out of memory. So I'm going to come in, go to the firewall, into the reverse caching proxy, check here, get this out of memory, come back, and it goes to the client, all without going to the origin server, which is the thing that's taxed at the moment. So this is very helpful. And actually, I'm going to color code that green because it'll make sense in the logs later. So then eventually this stuff will expire, and then another user is going to come along and they'll make a request for slash, go to the firewall, into the caching proxy, check here, it won't be here, they'll go back to the server and complete the entire transaction. And this is, if you're requesting anything, so you're requesting some, some sort of JPEG or something like that, you basically, this user can roll through and go for the JPEG. It will hit this different area of memory because we're storing it in a different location, come back and populate that and come through. That is, in essence, how the reverse caching proxy works. I know this is kind of a mess, but yeah, you can see that when you make the request, there's probably definitely going to be certain types of requests that you don't want to cache. Anything that maybe goes to, say, a WordPress admin console or whatnot. So I've added a nice little exclusion list to prevent people from, or prevent those particular pages from being cached. And so one can use that if they don't want the caching to take place. You'll see here there's also a basically a little 5-minute expire window, and that means that at 5 minutes an event is fired and this thing is cleared out, and the next client that comes through will have to repopulate the cache. And the nice thing is that the origin server, because it's totally taxed, it only has to serve requests on a very, very infrequent basis for the sites that we're caching. Also, I should mention that the sites don't cache posted data. So if the header is a post request, it basically doesn't cache that. It allows that to go through. So here are the logs, and you can kind of see the color coding here. Basically, these are all requests for particular types of documents on the server. And the red ones are the ones where someone's requesting them, but they don't already exist in the cache. And so it's populating the cache off the origin server. These yellow lines here are basically expirations from the cache, and the green lines are all hits and content that's being loaded directly out of the cache, and it's very, very fast. So that's it. There's a bunch of really cool things that we can do with this in the future. This isn't even a 24-hour-old piece of software, so it's probably going to have a fair amount of bugs and kinks that we have to work out. But for now, I think it should give us a pretty decent amount of relief whenever anybody gets hammered. That's it.